Hello, welcome back to our channel. Today's our topic is the kinetic theory. This is also one of the very important chapter and very easy chapter, and it is the last chapter from the first year. The chapter name is the kinetic theory. In this chapter we are going through the and we are discussing that we are relating the macroscopic properties of the gases like pressure, mass, volume, temperature to the microscopic properties like that moment of that molecules, force of that one, and random moment, mean free path, kinetic energy. We are relating to that one. So this is the kinetic theory. In this we are starting with gas laws. What are the gas laws? Gas laws means immediately we are thinking about the first one is the Boyle's law. At constant temperature, pressure is inversely proportional to the volume for the given mass of the gas. Already in previous thermal properties of matter we discussed that P is inversely proportional to the volume. Then you know the Charles first law and second law. Based on that three laws, you know that ideal gas equation also. What is ideal gas equation? PV equals to nRT. P is the pressure, V is the volume, N is the number of moles, R is the universal gas constant, and T is the absolute temperature. When we are going through the two gases comparison, we should write it P1 V1 by N1 T1 equals to P2 V2 by N2 T2 also we should write it. Then from the Avogadro's number, the number of molecules occupying per unit volume for 22.4 liters of that one. You remember this value, it is playing an important role here. That value is how much? 6.023 into 10 to the power of 23. Then we can go to the number of moles. For number of moles we can express mass of the gas by molecular weight also. Here mass of the gas is represented by small m and molecular weight is represented by capital M. Not only this one, in terms of Avogadro's number also we can able to write it. Number of molecules are represented by N. Avogadro number is represented by N. So from this most of the people are confusing here only. N is the number of moles. We can take 1 mole, 2 mole like that. Sometimes we are expressing in terms of that. They are giving mass of the gas is grams and particular gas like hydrogen, helium like that. So you can take in terms of N, mass of the gas by molecular weight. Sometimes they are giving like number of molecules, N value they are giving. So immediately you can take it instead of small m, number of moles equals to number of molecules by Avogadro number. So be ready to take any formula, depends on the situation, especially for small n. Remaining are same. And one more thing you should remember while using the gas laws, we must use the absolute temperature. Even they are giving in degrees centigrade, we should convert into kelvins. We have to add 273. Then you should convert from degree centigrade to the kelvins. Now one more formula. Universal gas constant you can express in terms of Avogadro number and Boltzmann's constant also. What is that? R equals to Na into Kb. Na is the Avogadro number, Kb is the Boltzmann's constant. Now we are taking ideal gas equation. PV equals to, here I have taken number of molecules by Na instead of that moles. After simplification you can express this ideal gas equation. Pressure, look here, pressure what we are getting here, pressure P equals to N is the number of molecules, Boltzmann's constant into absolute temperature by V. So this is what we have used instead of small n, number of molecules by Avogadro number. And one more side what we are taking here, we can take it, this is the PV equals to, instead of instead of number of moles we are using mass of the gas by molecular weight into R into T. You know that mass equals to volume into density. So volume cancel. Here you are getting pressure equals to density into universal gas constant into absolute temperature by molecular weight. Here also pressure and here also pressure, but this is in terms of that Boltzmann's constant and this is in terms of the density. This is in terms of the density. Look here, both are belongs to pressure only, but depends on the situation we have to use this one. Then we are going through the pressure of an ideal gas. We are taking one cube. Inside we should consider one molecule is having the random moment. See, average velocity Vx square under root Vx square plus Vy square plus Vz square. Vx is the velocity along the x-axis, Vy is the along the y-axis, and Vz is the along the z-axis. Now delta t, time is how much? General formula for time is the distance by velocity. But here you consider this is moving along the x-axis and it makes the collision. It travels a distance L and comes back with same velocity. So total distance is how much? L plus L, 2L. 2L by Vx. So you should remember general formula. Change in time or time interval is how much? 2L by Vx. L is the length or distance covered by this one. When you know the time interval and you know this, then you can find out the change in momentum also. Mass into velocity. But change in momentum while striking this wall and while coming back, change in momentum, you are getting 2m into Vx. Why we are taking the Vx? We are discussing this motion along the x-axis. Then when you know the momentum and time interval, you can find out the force is change in momentum by time. After simplification, we are getting that mvx square by L. Instead of L, what we are taking? We are taking distance by velocity, that one. So after simplification, we are getting mvx square by L. Then after simplifications, you are getting that in terms of RMS velocity, v bar square RMS means simply we can take it v bar square also, it is representing the RMS velocity of that one. RMS velocity of these molecules are formula is like this. V1 is the velocity of first molecule, V2 is the velocity of second molecule, V3 is the second of that one. Then average of all under root V1 square plus V2 square plus so on and so on, Vn square by n. It is giving the RMS velocity. Here kinetic energy, from the kinetic interpretation of the temperature, kinetic energy equals to 3 by 2 into kBt. From this what we are saying, kinetic energy is directly proportional to absolute temperature. Then Vrms equals to under root 3 RT by molecular weight. It's very, very important. Root means square, velocity is how much? Under root 3 RT by m. T is the absolute temperature, R is the universal gas constant, m is the molecular weight. Already I have discussed previous year's kinetic theory problems. Most of the problems are coming from this. Most of the problems are they have given based on this under root 3 RT by V, and they have given in terms of specific heats also, relations also, Cp minus Cv equals to R, that also they have given that, and degrees of freedom also very important. So finally you should remember all formulas, not too much. This chapter is very small, easily you can able to remember that what is ideal gas equation, what is the number of moles in terms of mass and molecular weight, in terms of number of molecules and Avogadro number. Then this is the time, this is the change in momentum, this is the force, and this is the pressure. When we can go through the pressure and density relation, P equals to 1/3 P Vrms square. Velocity root mean square is, this is one formula when you know the velocities, and this is another formula under root 3 RT by m. Not only this one, we can go through we know that velocity of sound in gases, from that V equals to under root gamma RT by m. V equals to under root gamma RT by m. What is the gamma? Gamma is the ratio of the specific heats, and you know the relation between Cp and Cv also. Cp minus Cv equals to R. All these formulas you should remember for this chapter also. Anyway, come here. See, then velocity of the sound in gases, Vg equals to under root gamma RT by molecular weight. Just now we know that Vrms equals to under root 3 RT by m. When we are taking these two relations, Vg by Vrms equals to, you can get it, gamma by 3. See, depends on the situation. Here gamma is playing an important role. Gamma is different for different gases. One is the monoatomic gas, diatomic gas, polyatomic gas. Based on that we can take it. But gamma is the ratio of the specific heats. Then we are going through the degrees of freedom. For the degrees of freedom means the possible ways to movement of that one, that is called the degrees of freedom. So for monoatomic gas, each side, that is what 1 by T kBt. So here individually you should remember that for monoatomic gas, you should remember that Cv equals to 3 by 2 R. When you know the Cp equals to plus R means we are getting 5 by 2 R. When you know these two, then gamma for monoatomic gas is how much? Monoatomic gas is how much? Just you can take the ratio of this one. We are getting 5 by 3. So total for monoatomic gas, we have to remember that these values, what is the Cp and what is the Cv. And one more thing you have to remember, that degrees of freedom. For monoatomic gas, the energy of the molecule is the 3 by 2 kBT. So this is the internal energy, and you can write it, this is the Cv and this is the Cp for monoatomic gas. Can you say what are the examples for monoatomic gas, like helium, lithium, and carbon monoxide, argon? These are the belongs to the monoatomic gases. Then diatomic gases, Cv is 5 by 2 R, then Cp equals to 7 by 2 R, then gamma equals to how much? 7 by 5. For polyatomic gas, degrees of freedom you can take it, Cv equals to 6 by 2 R, then Cp equals to how much? This is the 3 R means that is the 4 R, and here gamma equals to like H2O and CO2, that type of molecules we are using this. This is the 4 by 3. These are the degrees of freedom. You must remember for doing not only this chapter, for thermodynamics also it is useful for this what is Cv, Cp in the case of monoatomic gas, diatomic gas, and all this. Then last concept is the what is the mean free path, that is represented by lambda. The distance between two successive collisions between the molecules is called what? Mean free path, that is represented by lambda equals to 1 by root 2 pi n square into d. Root 2 pi n square into d. So that is the mean free path. And here you should remember that is the d is the, here kT also is there. K belongs to Boltzmann's constant, T is the absolute temperature, N is the number of molecules per unit volume, and D is the diameter of that molecules. So this is about the kinetic theory of gases. Very simple chapter and easily you can find out, and in between you have to read that what is the Dalton's law and what is the Graham's law, and already you know in chemistry. Once you should revise all these laws. Thank you everyone. Please subscribe my channel.